Remember back in 2020 when everyone was playing Among Us? If you're anything like me, you probably thought, man, that looks fun. Too bad I have 0 friends to play with. So today we're going to fix that. We're going to recreate Among Us from scratch and replace all those pesky friends with 9 different instances of ChatGPT. That way, anybody can enjoy a game of Among Us regardless of how cripplingly lonely they are. First things first, we need a map. I didn't want to do an exact copy of an existing Among Us map, so I tried coming up with something at least a little unique. Here's my first version. There's no real logic or reason to anything here, I just wanted to throw down some rooms and see what came out of it. Then we have the Godot staple, which is a character controller with a color rect on it. We also have our computer controlled characters, which for now, I just spawn them in a random room. Then they look at this table I've created to know which rooms they have access to, and then they just move to an adjacent room. I've also added a kill button, which for now just destroys the victim from the game entirely. I made a meeting scene that the game will switch to when a dead body is reported or when a player calls an emergency meeting. It also has a chat where the players are able to talk to each other. For now it's pretty ugly, but it's still better than most of the concept art that I usually make. Voting also works, though for now it only checks which vote the human player made. The CPUs don't get to vote yet. Next up is tasks. Tasks are simple little activities that the crewmates do across the map. Each crewmate is given a list of them at the start of the game, and if all crewmates complete all of their tasks, then they win the game. I made some classes to hold each player's tasks, and then assign them randomly at the start of the game. Then, the player has a secondary state machine which has a unique state for each task. That way I can easily change the inputs and UI elements for each one. When I was designing this, I mostly just focused on the tasks that are basically just a progress bar, because those are the easiest. We've also got the task list up in the top left, which enumerates all of the player's tasks. The imposter will still see this list as it helps them know which task to fake. Rather than waiting until the very end of development, I decided to try and get a jump start on artwork this time. I wanted to try experimenting with vector art, since I've only really tried pixel art before, and since Among Us is most certainly not a pixel art game, I figured this was a good time to try something new. If you don't know what vector art is, the gist is that you draw using shapes and lines instead of pixels. The benefit of this is that everything is infinitely scalable, since vector graphics can just calculate what a higher resolution image would look like based on the shapes that are used. Here's what my finished tile set looks like. You might think that this looks extremely basic, and you would definitely be correct about that. I really struggled to get a handle on this vector art program, and it took me way longer than I'd like to admit just to get some basic squares placed in the right positions. If I had to redo these tiles from scratch, I bet I could do it in a quarter of the time. Nonetheless, I think I understand vector graphics better now, and I don't regret spending the time to learn more about it. Here's what these tiles look like after I've placed some of them onto the map. The next order of business was pathfinding. I have 9 computer-controlled characters here. I need them to be able to navigate this map that I've created without getting stuck or wandering aimlessly. So it's about time I learn how on earth 2D navigation works in Godot. Alright, so I think I figured it out. Basically, you have to draw out your map onto one of these Navigation Region 2D nodes, and then give the CPUs one of these Navigation Agent 2D nodes. And then, as long as the positions are set correctly, the agent will only operate within the confined space. That's great and all, but what about obstacles? If the CPUs can't figure out how to avoid a table in the middle of the room, then there's not really a point to any of this. Enter the Navigation Obstacle 2D node. Based on how I've described the region and agent nodes so far, you might think this one sounds easy. Just chuck it under a solid object, give it a shape, and everything will just work. Well, yes, actually. But for some reason, it did not work easily for me. I had to spend way too long trying to convince the stupid obstacle to act like an obstacle. Lucky for you, you get to skip all of that and just see it now that it actually works properly. At this point, I came to the realization that I was definitely not going to make art for this whole game. So I just caved and stole the assets from the original game. It's just not worth my time right now to spend 2 weeks remaking assets. So now we've got the character sprites and background details from the original game. Stolen art sure makes everything look a lot better, huh? I went and stole some UI elements as well. Now we've got HUD buttons for using, reporting, and killing, the dead body animation works, and we can also hop into vents and move across the map. I've also touched up the emergency meeting UI with a mix of polish and stolen assets, and I think it looks a lot better now. The chatting also works and I can type messages. The eject screen also got a makeover, but I thought recreating the original was too boring, so I went with this instead. Lastly, we've also got game over screens for when both the crewmates and imposters win. Finally, it's time to really talk about how these computer-controlled characters are going to work. My plan is to have two different sides. One side will control them during the overworld gameplay, and the other, which is ChatGPT, will control them during the emergency meetings. Like all good things in game development, the overworld CPUs are controlled by a finite state machine. The basic idea behind it is that they have a state called the decision state, where they decide what they want to do based on their surroundings. For example, if they're in a room with a dead body, they'll report it. If they have an unfinished task in the room that they're currently in, they'll do it. If they're an imposter and there's only one other person in the room, they'll kill them, that kind of thing. Each of these possibilities is represented by a state in the state machine. Now this is interesting and all, but you probably clicked on this video to hear about the other part, that is, the part controlled by ChatGPT. ChatGPT has its own API that you can access by spending a few dollars on tokens. Tokens are basically the cost of using the API. The more context and instruction you give in a request, the more tokens will be used. You can access the ChatGPT API in Godot by using an HTTP request node. As long as you give it the right headers and API key and whatnot, the API will give you back your answer in about 2 seconds. Since we have 9 computer characters, that's 9 HTTP request nodes that we need to run simultaneously. We'll come back to that in a moment. For now, we need to come up with a way for ChatGPT to understand everything that has happened in the game before the meeting was called. Since it isn't the one controlling the game in the overworld, it has no idea what went on. It doesn't know things like what tasks they've done and who has died so far. My solution is this autoload script that I wrote called the event log. In a nutshell, the event log is a giant array full of every noteworthy event that has happened since the game started. An event is anything like a character entering or exiting a room, doing a task, or killing another player. All of these events are stored in the event log. We can't just pass this giant list to ChatGPT as it is though, because then they would basically be omniscient, and they would see things happening all the way across the map. My solution is this satisfyingly simple little function that tracks a given player's location as it iterates through the event log, and then it only returns the events that the player was in the same room for. This solution has a few minor flaws since everything is based entirely on what room you're in. That means that a player that dies 5 feet away from someone could go undetected as long as it was in a different room. That being said, I think this is a sufficient enough solution for what I need. Now that we have a list of everything that's happened, we just need to go through the list and display everything in a human-readable way, and then we can pass that to ChatGPT. That isn't the only info that ChatGPT needs though. It also needs to know what game it's even playing in the first place, what my modified version of the game looks like, whether it's an imposter or not, which characters are currently dead or alive, and what messages have been said so far in the current meeting. I passed all this info to the API by using developer messages. If you care what any of this looks like, you can just pause and take a look. With all of this info, ChatGPT is finally able to read my messages and respond in a semi-logical way. The biggest problem that I still had to solve was how to get 9 instances of AI talking to each other to not be overwhelming. In a normal group conversation, people know when to stay silent and only speak up when it makes sense. It also takes them time to type out their message so they aren't able to spam the chat with an essay every 3 seconds. ChatGPT does not have this limitation. If I query all of my instances of ChatGPT for messages, they're likely all going to reply instead of saying silent, and they're all going to reply at around the same time, which makes it very hard to read. Solving this problem was a multi-pronged approach. The first step was to make it so that the person who calls the meeting gets first dibs on speaking. This works well to get everyone on topic, and it also helps when the human character is the one who called the meeting since they'll get more time to type out their message before the chat gets filled with responses. The second step was to give each player a timeout in between each message, and to stagger the messages so that they don't all try and respond at the same time. Lastly, I added a bit more instruction in my prompts to really try and convince the ChatGPT instances to not reply if they don't have anything unique to say, which is a major waste of API tokens on my part, but so be it. This improved the readability of the chat a lot. It can still be too much at times, but that can happen in real group chats too, so I think this is fine. We also need the CPUs to be able to vote. When the meeting timer runs out, I send another prompt out to each ChatGPT instance asking who they want to vote for. I can then tally these votes up alongside the human player's vote, and we can use that to choose who to eject. I'm happy that all these ChatGPT instances are communicating properly, but they seem to be acting super rigid. They don't really talk like they're playing a video game. Among Us with Random People is known for its high level of intelligence, so let's try and inject them with some personality. I made this list of random personality traits to send to ChatGPT. Then I split up these traits at the start of the game and assigned them to the players. I also gave every player this trait, which helps them speak more like an actual gamer. The results kind of vary in terms of quality, but once again, Among Us with randoms is not exactly the peak of the IQ scale either. We're basically finished at this point, so it's time for some final polish. I've been ignoring the tasks for a lot of this project so far, but currently they still look like this. So I stole some more art assets and made sure everything actually works properly. The tasks that I ended up creating are download, refuel, wiring, chart course, scan, calibrate distributor, and Simon Says. I also added some of the important sound effects, like the kill sound, the task complete sound, and of course, the report sound. I'm gonna make the call and say that the game is done. I've been playing a few games of this, and I can't tell if I've utterly failed at my objective, or if I've created the most accurate simulator of online Among Us ever. These people are mean. On my first game, Blue killed somebody right in front of me. I called him out on it, and immediately everyone ganged up on me for self-reporting and voted me out. On the next game, I was an imposter. I got caught while making a kill, and nobody believed my excuses, and I was still voted out. On my third game, I had a kill happen right under me while I was doing a task. I called the person out, and was immediately accused of self-reporting again, and voted out. Besides those games, I did have a few good ones. I had this game where Blue and I were imposters. Blue and I each got a kill, but Blue got caught for his kill and was voted out. This meant I was a lone imposter against 7 other players. On the second round, I managed to get 2 kills. When Cyan reported it, he was accused of self-reporting and was voted out. On the third round, I got 1 more kill and then Green reported it as I was right next to him. He immediately sussed me out, but I was able to accuse Green of self-reporting hard enough that the vote was split. On the fourth round, I got 1 more kill and it was down to just 3 people. Green was oddly trusting of me after watching me fake some tasks, and Purple was busy speaking Old English, so I barely managed to convince Green to vote Purple, securing me the win. Overall, I've come to realize that these computer players really like to accuse people of self-reporting. Definitely something that may need touching up in the future, but I can't say it's wholly inaccurate. Unfortunately, I can't really release this to the public, both because of the stolen assets and because I don't have enough money to just hand out API tokens for free. Nonetheless, I hope you enjoyed. I'm hoping to do more stuff like this in the future.